Okay, please do not watch this video until you have tried this problem on your own. So if you haven't, pause the video and go ahead and try it. Okay, in the case that you've already tried it, you can forward to the end, but I'm going to work through it in case you're confused. So we have a cart with mass M2 is connected to a mass M1 using a string that passes over a frictionless pulley as shown at the top right. Initially, the cart is held motionless. The tension in the string is question mark. So I'll go ahead and start by drawing two free body diagrams for each of the masses. So for M2, we of course have, so I'm going to first identify the forces on this thing. I have tension. I have the force from the finger. I have here some kind of normal force. And of course we're going to have force of gravity as a long range force. And then there is likely some friction between the cart and the ground. So some kind of friction. And since it's being held motionless, we know that's going to be static friction because the two surfaces are not moving with respect to each other. So drawing the free body diagram, we have force of gravity acting down. We have the force of the finger acting down. We have force of tension going to the right. We have force of static friction going left. And we have the normal force going up. Alright, I'll go ahead and draw it down here so we can see everything clearly. So there is the free body diagram for that one. Now let's work with this mess. So there's one contact point here, which is tension force. And then there's, of course, gravity as the long range force. So we have force of gravity Fg1. And also I should have given this force of gravity a subscript for M2, meaning Fg2, so I can keep track of the values. And then I have force of tension going upward. Notice that I've used the same label for both tension forces because they are constant. The tension is constant throughout this continuous rope that's riding over a frictionless pulley. Okay. Now, this problem, we could sum the forces in X and Y here, and sum the forces in X and Y here. But what you'll see is this is the situation where the cart is being held motionless. And in that case, we know the acceleration of each of these objects is 0. And this object is actually a lot easier to work with because it only has two forces acting on it. So for M1, if I do the sum of the forces in the y direction and I assume up is positive y and down is negative y, I get the following equation. I get Ft minus Fg1 is equal to MAy1, meaning acceleration of object 1 in the y direction. Well, I just talked about the fact that this is 0 because it's in equilibrium. So then we can say that force of tension is just equal to Fg1, which we know is M1G. So the correct answer is here, A.